Welcome to MyProjectBazaar.com. Let me discuss about the project, a novel energy efficient clustering based cooperative spectrum sensing for cognitive radio sensor networks. Let me discuss about the abstract of the project. In cognitive radio system, secondary users can be coordinated to perform cooperative spectrum sensing so as to detect the primary user more accurately by separating all the secondary user into a few clusters and selecting the most favorable users in each cluster to report to the common receiver. The proposed method can exploit the user selection diversity so that the sensing performance can be enhanced, increasing energy efficiency, network lifetime, network stability, and optimal cluster head selection process. This paper proposes a novel energy efficient clustering based on cooperative spectrum sensing, that is ECS for CRSNS. Advances in wireless sensor network technology has providing the readiness of small and lower cost sensor nodes with aptitude of sensing various types of physical and environmental surroundings. This is based on standard election prospects of each node to become cluster head, conferring to enduring energy in each node. The recreation result shows that the cooperative spectrum sensing yields extended stability sections for higher values of extra energy taken by more powerful lumps. A heterogeneous aware protocol to prolong the time break before the death of the first node, which is important for many tenders where the repo from sensor network must be unfailing. The sensors are self-rolling small devices with several limitations like the battery power, deviation, capacity, communication range, and memory. In this paper, propose a new data furthering access to improved lifetime of wireless sensor network using entries. Let me discuss about the flow diagram for our process. Initially, the sensor node deployment. A random deployment has been performed. Each node is equipped with cognitive radio capabilities such as spectrum sensing, dynamic spectrum access, and transmission parameter configurability. Deployment of node is random, dense, and redundant. Nodes that belong to the same cluster should have at least one common available channel that is not currently occupied by a neighboring primary user. Each node is randomly deployed in a region, and its location is determined with the global positioning system that transmits its location along with the application type and the node identification number to the fusion center or base station. The effectiveness of DSNS is determined to a large extent by a coverage provided by the sensor deployment. Positioning of sensors affects coverage, communication cost, and resource management. Next, the cluster head selection has been performed. Here the cluster and also cluster head selection are formed. Each node uses stochastic algorithm at each round to determine whether it will become a cluster head during this round. Cluster heads selected after the first round are determined based on the remaining energy of each node. Furthermore, only nodes in awake mode engage in the cluster head selection process. If the random number picked by a CRSN node in awake node is less than the threshold, this node will elect itself as a cluster head, that is as the primary cluster head PCH. When node has been selected as a PCH, it broadcasts an advertisement message to the entire network. Then awake sleep node configuration. Both nodes in a spectrum aware coupled pair take turn switching between awake mode and sleep mode after each round. In awake sleep mode setup for coupled CRSN nodes algorithm, the node first checks whether the spectrum aware coupling has been done. If the node is coupled, then one of the nodes in the pair will check whether it is in awake mode and whether it is a flagged as SCH for the next round. If the SCH next round flag is on, then the same node will be in the awake mode during the next round and the other node will remain inactive. If the node in awake mode and its SCH next round flag is off, then the current node will go into sleep mode and the other node will take its turn in awake mode for the next round. Finally, if energy of the awake mode is less than the energy minimum, then the awake and sleep mode configuration has been performed. If not, means then data transmission will be performed. Data transmission by the node to cluster head, data received by the cluster head from the node, aggregate data by the cluster head, aggregated data transmission to the fusion center. During the data transmission, if a bit image from a node to cluster head, each node dissipates energy to run the transmission circuitry and for the transmission amplifier to reach an acceptable signal to noise ratio. Finally, once the iteration will be reached maximum iteration, then it will be stop the process. Finally, performance has been analyzed. Stability period, duration of CRSN performance from its initialization until the first node dies out. Network lifetime, duration of the CRSN's performance from its initialization until the last node is alive. Instability period, duration of the CRSN's performance from when the first node dies until the last node dies. Let me discuss about the running procedure for our process. Select the main.m file in the current folder and right click the file and run for executing this process. Here both cluster and cluster head selection will be performed. This process will be repeated for maximum iteration. Once the cluster head will be selected, then the energy estimation energy is less than the maximum energy will reach, then the data transmission will be performed. This process will take more time for executing. Here this is the execution of the process. This is the node and fusion center location, and this is the fusion center representation. Nodes are deployed randomly. Here the cluster head will be selected, that will be displayed with magenta color, and here associate cluster group. Here every cluster head transmit their data packets to their fusion center. This is the received data at destination. Here the initial energy and remaining energy. This is the cluster head cluster formation for every cluster radius. This is the energy level and number of rounds versus energy level between existing scheme and our proposed ECS scheme, and this is the number of dead nodes versus number of rounds between PSO scheme and our proposed ECS scheme. This is the number of alive nodes versus number of rounds for our PSO existing scheme and our proposed ECS scheme. This is the number of packets delivered when increasing the number of rounds for PSO and our proposed ECS scheme. This is the number of packets versus number of rounds between existing PSO scheme and our proposed scheme. Finally, we achieved maximum number of packets delivery and minimum number of dead nodes using our ECS scheme. Thank you.